Principles of Compiler Design. This is Dr.K.N.Sivabalan. In today's video lecture, we will be learning about recognition of tokens. What is meant by recognition of tokens? A token will be recognized with the help of using a pattern. The pattern is actually formed with the help of a regular expression. So this regular expression, when it is applied in a state diagram, then obviously the respective tokens will be recognized. So we'll be learning about the various ways of recognizing the tokens. Now the tokens are actually recognized using a set of transition diagrams. In other sense, it is called as state diagrams. There are different types of tokens recognition, spanning from recognition of identifiers, relational operators, keywords, and numbers. We will be having a detailed demonstration of all this recognition of different set of tokens here. Now first we will discuss about what is meant by an identifier. So how it is actually a regular expression is written for identifier. In short, an identifier is called as a variable or a function name. Anything which have a user defined name is called as an identifier. The rule for an identifier is it should start with a letter, or other sense it should start with an alphabet followed by letter or set of digits. Even if it starts with one alphabet, then it does not follow with any of the letter or digits, then still it is considered as an identifier. Now what is meant by a letter? Letter is actually any alphabet, either it is small case letters or capital case. Everything is called as alphabet spanning from A to Z, and digits is actually we will have from 0 to 9, everything is called as digits. So this is a set of rules for identifying an identifier or recognizing an identifier. Now how will you state a state diagram? So how will you draw a state diagram for this? For instance, we will have a state diagram like this. There are two states here. One is an initial state and another is called as final state. An initial state is state number 1 and the final state is state number 2. Now the rule of an identifier, it should start with the letter. So when we apply a letter, we are moving from the initial state to final state. So even one letter is actually recognized as an identifier. Now it can be followed by any number of letters or digits. So we make a self loop in final state 2, where letter and digits can be repeated any number of times after following the first letter. So this is called as a state diagram for a regular expression for an identifier. Now the next is the recognition of relational operators. So relational operator is less than symbol, less than or equal to, greater than or equal to, and not equal to. Now you can see here, we start from the initial state called as state number 1, and there are 6 different final states here, which is actually used to recognize all these relational operators. So first we will start with less than symbol, and when we move on the top, we can see that less than symbol is actually followed by a greater than symbol. When in state number 2, it is actually considered as a relational operator not equal to. A less than symbol on the left side and the greater than symbol on the right side will result in a not equal to. Now coming to the second one, when I apply less than symbol, and if it is not followed with any of the alphabets, if none of the alphabets follow that, then it goes to state number 3, then it is called as less than symbol. Now again, if less than symbol is followed with an equal to, it actually goes to state number 4, and that is called as less than or equal to. Now we again move to state number 1. In state number 1, when we apply a greater than symbol, and in state number 5 it is not followed by any other symbol, then we move to state number 6, then that symbol is called as greater than symbol. And in state number 5, when we apply equal to, we move to state number 7. So that is considered as greater than or equal to symbol, because 1 to 5 is having greater than symbol, 5 to 7 we have equal to symbol, so it is called as greater than or equal to. Now in state number 1, if we directly apply equal to, go to final state called as 9, So we make that as relational operator equal to. So altogether we have 6 different states, but here we are actually returning 2 types of attributes here. When we found a particular token, or when we find the relational operator, here we actually, the first portion actually says that it is a type of relational operator, and the second is actually says that its value. So not equal to, NE is called as not equal to, LT is called as less than, LE is called as less than or equal to, GT is called as greater than or equal to, GE is called as greater than or equal to, and EQ is called as equal to. Now we will go to recognition of keywords. Keywords are actually called as reserved words, which actually gives a specific meaning to the respective language. For instance, when I say if is actually called as a condition statement, which is used to check the conditions. Else is called as an alternative form of condition. If the first condition is not true, then it actually goes for the second condition. For that, actually we actually have else here. And for is actually a specific keyword which is used for iterative computations. So we have written a rule for recognizing a keyword for 3 different keywords: if, for, and else. Okay, we start from state number 1. When I apply I, it goes to state number 2, and when I apply if, it goes to state number 3, so that if is getting recognized. In state number 1, when we apply E, it goes to state number 4. When L is applied in state number 4, it actually goes to state number 5. When S is applied, it moves from state number 5 to state number 6, and when E is applied, it moves from 6 to 7. 7 is called as a final state here, so else is recognized. Now, in state number 1, when I apply F, it goes to state number 4. So there is a small change here. It should not be state number 4. It is 8, 9, and 10. It should be 8, 9, and 10. So I just make a small change here. It is state number. This is state number 8, and this is state number 9, and this is state number 10. So 10 is called as a final state here. So with this 8, 9, 10 are actually used for recognizing the keyword called as for. So this is how actually it continues. This is called as the state diagram for recognizing the keywords. Now we'll go for the next one. The last one is called as recognition of numbers. So a number will be for start with a digit and followed by any number of digits. So I have written a rule here: number tends to digit, and digit can be followed by set of digits. So digit star. And what is that digit? Digit is actually spanning from 0 to 9. Okay. Now we will construct a state diagram for it. When in state number 1 is called as an initial state. When we apply 1, when digit is applied in state number 1, it is actually moving to state number 2, that is called as a final state. In state number 2, we can have 0 or more number of digits applied to that. So this is called as a state diagram for recognizing the numbers. So that's about recognition of tokens. Thanks for watching a video. Have a good day.